Let's wait for one more minute. After that, I will start the session. Okay, let's start. Welcome to the third tutorial session of Operation and Planning of Power Distribution System. Whose professor is Sanjeev Gangli sir from IIT Guwahati, and I am Satya, a PMRF research scholar here in Department of Energy Science Engineering, IIT Bombay. So in the last two tutorial session, we have seen the few problems which actually helped you to solve the assignment one and assignment two. Here we will solve the problems related to that will help you to solve the assignment three. And in this, we will see the substation and also the bus bar, different topologies and different configuration, radial and uh, circular feeders. Okay, let's move forward. Try to solve the first problem. Okay, here I have given one of the problems related to the insulated substation. Suppose there is a switch gears and all. So, okay, so this question is related to that ki, if it is a gas insulated Vilas, please switch off your mic. Vilas, yeah, thank you. So this is a question related to the gas insulated substations, which are generally preferred in the urban areas. So you have to tell me that why it is actually preferred. Why not air insulated substation is there or any other kind of insulation methodology in the urban areas basically. Okay, when you see the urban areas, so this is generally preferred the gas insulated GIS substations. Okay. You just have to tell me that why it is so. So there are four options are there. You just have to tell me which option is actually correct. Okay, option two. I got any other. Let I will give you 30 seconds to just read the problems and come to a solution. Okay, option three are cheaper than the outdoor substations. Okay, just wait for a few seconds and after that I will give the solution. Okay, let me give the solution. Actually, this occupies less space, so that's why the urban substation, urban areas, it is preferred. So you can see in the picture, this is a one gas insulated switch gears are there in the substation. So actually, they need very less space because you see the structure. This is actually occupying less space and can be installed in the cities with a higher population density because the space constant will be there. Okay, so that's why this GIS substation is preferred. They are expensive because you have to put the gas insulated switchgears that is actually costly, and this requires because the maintenance is actually cost is lower and the reliability is high because you don't need to frequently change this. Okay, so that's why you need a certain system which is more reliable as compared to the other systems. Okay, so that's why it is preferred in the highly congested areas. Okay, let's move forward. This is a problem related to the substation location. So suppose I am actually putting a substation, so what are the criteria should I take care of? Okay, so that it can be economical and it could be loss can be minimized. So in that basis there are few options are there. You have to tell me that which statements are actually correct in there. Just read the statement properly, and it can be multiple statements can be correct. Any answers? Okay, I got all of these. Anyone else?
Number three.
Okay. Okay. Let's wait for others also to solve. Let me give you one 30 seconds more to solve. Okay, let me give the solution. I got few of the. Okay, let me give you the solution. Option three. No, no. Actually, all the options are actually correct. So here, when you see the A substation is usually located close to a load center of its service area. That is so because if you have the shorter distance, the losses will be minimized. So suppose the as soon as the you have a substation where the you have a distribution transformer and there is a bus distribution feeders are there. Okay, so as it is lower to the substation is load closer to the load center. Suppose this is substation, you have a substation transformer, different equipments are there, and you are closer to the load. Okay, so this is the line which you are using. So if it is like that, so okay, so this line you say this is a farther system from the load center, and this is closer. Okay, so the losses will be is proportional to the length. Okay, as soon as the length will increase, the losses will increase. So that's why substation is usually located near to the load center for of this service area. Okay, so a substation location influences the voltage regulation. That is true because voltage regulation. So suppose this is a sending in and this is the receiving in. Okay. So as soon as when you see the length, suppose this is the length. So okay. So here suppose this is VR2. So in this case, when you see the VR voltage VR will be lower than the VR2. Okay, so when you see the percentage voltage regulation formula, it is simply equal to Vs minus Vr divided by Vr. Okay, so as soon as when you see the voltage drop increases, or you can see the delta V basically. So as soon as this Vr2 decreases, Vr2 decreases. Okay, so if it is decreases, then delta will increase. Okay, so the voltage as farther in, if the voltage will drop down because the losses will be there in between the line, so the Vr will reduce and this delta Vr will reduce. So this delta V will increase and voltage regulation will be increasing. So that is not required. Basically, voltage regulation should be as minimum as possible. So it actually influences the voltage regulation. Third is substation location should be such that it is provide proper access to the incoming substation lines and outgoing feeders. That is true because when you have the substation, it should have a certain proper access of incoming substation line, and there is a right of row, and also the line accommodation should be there. So an outgoing primary feeder should be also is. Suppose here when you see this is a distribution transformer, so line which is coming incoming lines and there is a outgoing lines will be also there. So it should accommodate that. So there should be enough space around that. Okay. Fourth, it is saying a substation location should provide enough space. That is true. That if in further the load is going to increase, so you need to have a larger radius cables, and also more insulation will be required. And then you further you change the distribution transformer. You need the bit higher capacity distribution transformer. So enough space should be there, so it can be replaced and new one can be put it. And also the choice of substation depend upon land use regulation, local ordinance and neighbors. That is true because you need a space, so that's why the and it should be at a regulation free. Means that you already have the permission to expand and you already have the enough space in the future you want to accommodate uh, uh, different equipments in that. So all the options is actually correct in this. Okay. Let's move forward. Try to solve this problem. This is related to the which component basically in the service substation determines its rating in the primary distribution substation, which is the equipment which actually defined its rating. Try to solve this. Vilas, can you switch off your mic, please? Okay, option one, I've got. Okay, that's true. Basically, let me give the solution that when you have the rating of the service station sub transformer, when you know, so it can primarily define the distribution substation. Okay, whatever the actually feeding from that substation will be there. Suppose this is distribution transformer and you are connected to some bus bar, and there is a some line is there, and then you have the loads and further line, and the further loads will be there. So in that, when you see the whatever the rating of this transformer will be there, so this is practically define the what the substation rating will be there. Okay, suppose this is 1250 MVA. Okay, so this is kept because the loading requirement of the line, whatever the loads you are going to feed, it is actually in that range. Okay, so what in the previous classes what I have told, 70 to 80% loading is permissible. Okay, in the distribution transformer considering its rating and all. So this 70 to 80%, that's why this loading whatever is there, so it should fall in the 70 to 80% range of the 250 MVA. Okay, suppose the loading got increased. Okay, loading got increased, so here the considering the safety margin, so you have to use the higher rating. The transformer rating will also going to increase. Okay, because you're not going to supply this much loading which was initially there with that distribution. You have to change the transformer. Okay, so suppose there is a distribution substation is there, and there is a different loads are there. Suppose the electric vehicle loads which is coming new into the system, so it is going to increase. Okay, suppose there are five houses, and there was initially no EV penetration was there. So each house added the EV in that. Okay, five EVs. So this loading got increased. Okay, so now to accommodate this overall charging demand, you have to use the higher capacity distribution transformer. Okay, so that's why you should not overload this, because 70 to 75% loading should be maintained and should not be higher than that. Okay, so you have to change the transformer in that case. Okay, let's move forward, try to solve this. So I wanted to explain here, because when you see the bus bar arrangement, this was quite confusing, and it was explained in the video lecture, but I wanted to show you further that I wanted to explain it. Okay, so there are different types of, you just have to listen what I am saying. Okay, there are different types of bus bar arrangements are there. What there in the slides is also there. Single bus bar scheme, single bus with sexnizer scheme is there. Single bus with sexnizer and two power distribution transformer. Main and transfer bus scheme, double bus bar scheme, and we will see one by one. Okay, breaker and half scheme is there. When you see here, this is a one image I have kept here. When you see here, so this is a one point. Let me take another pen. When you see here, suppose this is a point one. This, when you see, this is a point two. Suppose this you see the point three, and here even you see this is a point four. Okay, so this is a RYB line is there, and this is the neutral. Okay, so when you see here, so the incoming lines are there, no, so here the incoming lines are coming here. So this is in the off state. When you see, this is the lines. Okay, this phase lines are coming here. Okay, then it is connected to here, the metallic strip is there which is connected to this circuit breaker. So this is a circuit breaker which is connecting this strips. So this strips is basically called as a bus bar. So suppose I wanted to explain here. So so this is a bus bar box. Okay, so you have a three strips here. So this is a R, this is Y, and this is B, and you have a one of the neutral. Okay, Suppose the incoming lines will be there. Suppose there is an incoming line R came, then it came with the Y. There is a B line is there. B is there, and then you have the neutral which is connected, which is common. Okay. Now you wanted to feed a load. Suppose this is a house. Okay, and you wanted to feed it the power to this. So from the R phase, this is single phase line. So feed it to there. Okay, neutral will be common. Okay, so this is a single phase bus bar which you have a single phase line which you have used from the bus bar. Okay, so R phases there is a limit that R should be this much, and based upon the 250 suppose MVA is there. So the current capacity will be decided for the each phases, the I rating. Okay, mod of I. Okay, so and y will be for some houses, and b will be some houses, so that the loading should not increase further. Okay, so this is a basic concept of the bus bar. So let's see the future, whatever the arrangement which are possible. So when you see the single bus bar, if you face any problem in between, just let me know. Okay, you can open your mic and ask, or you can type also in the chat box. Okay, so let's see the single busbar arrangement with the one main power transformer. Okay. So here one transformer will be there which is feeding to this line, and there is a circuit breaker in between. So here one circuit breaker is there in between, and this is a bus which is connecting with the different lines. Okay, which take to the different loads basically. So load 1, load 2, it is feeding you suppose two loads. So when you see here, there is a one single transformer is there. So this is a main transformer. It is connecting to one single bus bar. Okay, what three phase connection I have shown. So this is connecting to the one single bus. So at that bus only, suppose this bus is there. So at this bus only, there are different units are connected, different loads are connected, but the bus is single. Okay, so here this is quite simple arrangement. Okay, and the control and the protection is very straightforward, because you suppose I wanted to break this line, the loading got increased and we don't have, we wanted to protect our transformer. So what do we do? The load shedding we do. This is a one option. So to trip a phase line which is loads connected to one single phase, so we just trip the line. So and also no redundancy is there, because suppose I wanted to feed a load which is connected here. So when you switch off this bar circuit breaker, so in that the all load will be gone. In that case, you don't have any part to feed that load. Okay, so the redundancy is not there, and whole substation will be out of service while the power transformer circuit breaker out of service. Suppose this transformer, this power transformer got out of line, so in that case the whole substation will fall out of service. Okay, and the fault in the MVA will take place the whole substation out of service, because when you have a fault at this bus bar, the all current will go into that, because this is a low resistance path. Okay, so the all the power, all the current which is going, so it will go into this. Okay, so if the all the power is going into, so the load will not get supplied. Okay, so this is a kind of arrangement of a single bus bar arrangement with a one main power transformer. Suppose there is single other arrangement with the same system, but there is a two power transformer is there. Okay, suppose one distribution this power transformer goes out of service. In that case, you have other power transformer to feed this load. Okay, and through this bus bar. Okay, so that's why there is a redundancy is there, because when you wanted to feed this load, there is a two paths by which you can feed this load. Okay, in that case the redundancy got increased, operational flexibility is there, because you suppose this went to 70 to 80% loading. In that case, you can feed from this distribution transformer. You can increase, suppose this is operating at 50, just increase to 70%, so that it should not go above than 70 to 80% loading in that case. And the fault in the bus bar should be limited to one section, because here when you see, there is a CV connected here. Okay, through the tie line. So suppose this bus bar went into the faulty situation. So what we do, this open this. Okay, when you open this whole system go out of service, but this load will be supplied in that situations as well, because there is a you have to just isolate that bus bar. Okay, so in that case the other section will be in the working condition. Okay, so the reliability is high in that situation, but the investment got increased because you have to put the two transformer, the cost got increased, and higher no load losses as compared to solution with the one, because you have the multiple lines connected here, so that's why the losses will increase. Parallelization of power transform need additional control logic, because when to switch on this, when to switch on this, you have to make, suppose CB1 2 3 4 are there, so in that case you have to make a multiple logic 0 0 0 0 0 0 1 0 0 0 1 1 kind of operation you have to increase. So here when you see 2 to the power n means 2 to the power 16 kind of logic came into a picture, but here when you see the 1 is there, so 0 or 1 you have to on or off. Okay, or you have a 2 bus bar, then 0 0 0 1 1 0 1 1 kind of when to operate and when to leave. Okay, so this is a two arrangement of a single bus bar when you have a one main power transformer. Second is the when you have the two main power transformer. Third arrangement is single bus bar arrangement with a transfer bus. Okay, you have a single bus. This is a single bus only, which is connected to incoming line. Suppose there is a two incoming lines are there, which is feeding this. So in that situation, when you see there is a transfer bus is there here. So this is actually a transfer bus. Okay. So normal path, what will be the normal path? Normal path will be this transfer bus is not in operation. So when you wanted to feed this, suppose this line you wanted current in this, you just have to open this, and after that this will flow like this. Okay. Suppose you wanted to flow the current here, so it will be like this. And suppose you wanted to feed here, though the current will flow like this. Okay, okay, like this. Okay, suppose you wanted to maintain this, means some maintenance is required in the main bus bar. Okay, what to do in that situation? In that situation you have to disconnect, so you have to disconnect this bus, suppose all the bus, and then you have a one other redundant bus line. Okay, suppose this is the one redundant, so it is connected to incoming line, so it will connect it like this, so it will flow like this transfer bus, and then it will move like this. Okay, getting my point? So now you have a redundant bus bar, transfer bus is there, and you have an extra bus when you have a maintenance going on in the main bus system. So that's why this is a kind of arrangement is there. So this was the normal path and this was the changed path. Suppose this wanted to feed this load, so it will move like this. Okay, suppose you wanted to feed this line, so it will flow like this. Okay, so the kind of reliability and maintenance, during the maintenance on one circuit breaker does not cause any interruption for the load. So this is a kind of when the maintenance is there, you can use the transfer bus during that. Investment cost will be higher, drawbacks are there because you have to put the extra bus bar in there. Pull substation out of service in a bus bar fault case. Okay, suppose the main bus is out of service and the transfer bus got a fault. In that situation, the overall system will go into the out of service. Okay, protection auto reclosing circuits have to switch over the bus coupler bay during the transfer. Okay, so you have to this tie line is there, so bus bar couplers you have to switch on. Suppose this is there. Okay, you have to switch on in that case, so multiple protection or auto reclosing circuit have to keep. Suppose I wanted to see the double bus bar arrangement. Okay, so in that situation, suppose this is a one main bus is there, and you have a other which is this is a bus 2. Okay, suppose I wanted to transfer power to the line 1 here, so one will be like this now. So when the bus 2 is not operating, in that case the normal power will flow like this. So you have a same line, one path is there. Okay, suppose this bus goes out of service, in that case you will have, you can power this line through this. Okay, so here the double bus bar is there for a single load system. So Here the tiebreaker is there to switch on that key, the power will flow like this. Okay. So, but here the operation flexibility got increased because you don't have to put the multiple systems into the picture. You do have just two bus bars for a same line, and one could be operated at a time when the fault is there and the different conditions are made. And the effect of bus bar fault is limited because when the fault is there, you can operate the other. Here the fault is there, other gone. Okay. Here the fault when it comes, just disconnect the tie line. So this will be got out of service, but the second bus bar will be the functioning. Okay. And the substation extension possible under service because you can extend multiple systems you can connect and you can use that. Okay. Interlocking is complicated because you have to operate the two bus bar in a 0 1 logic formation. So you this is a complicated situation, but the logic should be given for a same system. Okay, like this. Uh, when the both are maintenance, it kind of means this is the this system when it is there. Suppose this is in the maintenance phase, so the whole line will get out of phase. That is what the double bus bar arrangement is. Suppose I wanted to see the what is the double breaker arrangement is there. So double breaker, when you see here, this is a one bus is there and this is second bus is there. Okay. So you can put the two bus bars, two breakers in between. Suppose this is the breaker one and this is the breaker two. And if I wanted to supply the power to this line, suppose this line I want to power the supply, so bus can be move, power can be flow like this. Okay. You can flow the power like this. Okay. And also you can do that, you can also see that you can also supply that power through this bus bar. Okay. Suppose I can power that line to this system also. Okay. So it kind of double breaker for a single line. So this is one two breakers are there. So that's kind of means not disturbing the service. When you read it, it will get more clarity. But the when you using the double breaker arrangement, here the investment cost got increased. Okay. Ring kind of bus scheme, it's a kind of when you have the ring kind of structure. So this is a one line here. You can also supply from this system to here. So there is a kind of ring based architecture will be there. So if one got out of service, you can reliability, you can transfer the power from the one line. So it's a kind of no means two section can be means without power at the same time. So that's kind of one isolation will be there, but the loading can be provided through the other line. There is a last scheme is there where the breaker and a half scheme is there. So here suppose this is two bus bar and there is a three breakers are there. Okay. So it's a kind of one should be on at a time, and through this bus also you can supply, and this is kind of disconnection is there. Okay. So the basically the bus failure does not remove any feeder from the section, but you can isolate it. Okay, when the fault is there in the one of the line. So this is kind of more reliable as compared to. So here it is written that since the middle breaker must be responsible to the either of the associated circuits, so it can make and after closing it, you can transfer the power to this line or this line as well for the different parts. Okay. So this is a kind of all the arrangement of the bus bar arrangements are there. So you just have to read it out once so you can get the clarity with what are the advantages, what are disadvantages of the different scheme, what I have explained. Okay. This is a one question here I have kept for the network topology when it is a radial or when it is a loop topology is there. So you have to just tell me that which option is correct. Multiple option can be there. So there are one, two, three, four statements are there. There are options. You have to tell me that which options is actually correct. Means which statements is actually correct. Try to solve this and let me know if any problem is there in understanding. Try to solve that. Okay, I got one answer as A, B also I got. Those who have given the answer, try to verify whether it is correct or not. Okay, then I will explain that, but try to see again. Okay, let me explain. So I got the few of the answer here. Option A, option B, option C also I've got. Okay. So when you see the what are the first statement is there, listen here. So first statement say primary distribution network are mostly radial, resulting in unidirectional power flow. Okay. Suppose you have a substation here, and this is a radial distribution feeders are there. So it's a kind of it will be looking like this. Okay. So it's a kind of when the power comes, it will flow like this only. This is a unidirectional flow will be there. Okay. So that is first is correct. That primary distribution network are mostly radial. They form the most network means ke 80 to 85% are radial networks are there. Okay. And second is saying that radial topology is preferred due to simplicity, low cost, and easier protection coordination. That is true because when you have the second what is the loop means when you have feeder like this. Okay, so this kind of network will be there suppose, and this also can be possible when you have load here. Okay, so the you bi-directional flow will be possible here, and here the cost will be more, the maintenance cost will be there, coordination is actually difficult. So here the when you see the coordination is easier. When you see the third option, radial topology is reliable. No, radial topology when you have a fault here, though it will go out of service. Okay, but when you have a fault here, okay, so it can be supplied from a suppose this is a some generating unit is here, so it can be supplied from this part. Okay, so it is possible. Okay, so radial topology is not that much reliable. Loop topology is actually reliable. Topology is commonly used in large cities. That is true. When you have a long distance transmission which is required, suppose the rural networks are there, feeders are there, so that they are of the long distances because the houses are located at a remote locations. So there the there you can see the large networks is required, so there the radial feeders are preferred. Okay, and when you have a large cities are there, okay, but they are constructed, the houses are in means nearby, so there it is possible that there is a loop topology can be there. Okay, so the option first, option second, and option 4 is correct. So option B is actually correct. Okay, so the 1, 2, and 4 is correct. So here also I have explained that what are the statements. Suppose the statement was primary distribution networks are mostly designed in the radial topology, which means that power flow in the single direction from the substation toward the consumer. What I have told like this. Okay, and this structure one supply part to each load points, and electricity typically flows outward from the source without reverse power flow. Okay, and when you see the statement 2, radial topology is widely preferred because it is simple to design, economical to construct, and easier to protect. And the fewer conductor switches, that is because there is a one single line is there. Okay, reliability is lower, okay, as compared to loop topology. And the loop topology is commonly used in the large cities or metropolitan cities when the reliability of power supply is critical. Okay, let's move forward, try to solve this problem. This is a kind of similar kind of concept, but when you have a primary feeder and a low density population, high density population, which is the primary parameter to be considered for the model? Okay, try to solve this. Okay, I got one answer as option A. Okay, let's wait for one option C, option B. Actually, two I got. Okay, let's wait for 1 minute more. And whatever you have given the answer, try to verify whether it is correct or not. Try to see the statements whether it is correct or not. Okay, let me explain this. Okay, so when you see what are the options it is saying, first is like the primary feeder in the low density areas are generally limited and permissible voltage drop rather than is the thermal capacity. Okay, so suppose you have a distribution substation is there, and you have, suppose this is substation is there, and this there is a feeder line is there, so this is connected to multiple feeders and which is supplying multiple loads. Okay, okay, like this. Okay, so that what I have already told. Okay, so when you have this length is very very short, what is there in the urban areas. Okay, in that the voltage difference when you see from here, this line, take another one. So from here to this line it is not much. Okay, so this is in the urban areas. But there is, when there is a rural areas are there, okay, so this line which go will increase further, okay. So that's why the voltage drop in line will increase, okay. So that's why when you have the high low density areas, that is the rural areas basically, so there the voltage drop is actually considered to be a primary factor in the primary feeders than the thermal capacity, okay. So the first option is what it is saying, that ki low load density areas, because the load requirement here is less, okay. And when you have the urban areas, there the load requirement is very very high, okay. So there the voltage drop is actually a primary criteria when you have a long distance feeder, okay. First is true. Second, what is saying, that primary feeder in the high load density areas such as the industrial and commercial regions are usually restricted by thermal limit. That is true, because here when you see in this location, in these locations the current is not that much, current is high but current is not that much. Suppose I consider I1 here, so and current flowing here is the I2, so I2 will be more than the I1, because there is a industrial equipments will be there and commercial reasons will be there, so the current requirement is very very high. So when you have this feeder line, what the current will flow here, so kind of that means कि suppose the here it is flowing 100 ampere is there, so thousand ampere is also there. So this is the main criteria, means thermal limit is major criteria to define, okay. So that is also correct when you have the high load density areas such as the industrial and commercial region, and this is the urban areas basically, where the commercial and industrial regions are there. So there the thermal limit is major criteria to define what are the current capacity, what are the wire will be there, what radius wire will be there, okay. So the second option is correct. So when you have the long distance feeder, so there is a rural area where the current requirement is low. So there is the voltage drop. Means voltage drop is a primary criteria to define the feeder line. And then the second is the when you have a congested area, urban area, high density areas. So there is the thermal region limits are basically the primary criteria. So the option A is actually correct. The first and second. When you see the third part, the low density area feeder length is mainly restricted to thermal limit effect than the rather than the voltage drop. So here the length is not that much, so that is not basically the primary reason to define the basically the drop. So here the heating limit will be the main, okay. So that is that is for the high density area. When you have the low density area, feeder length is very very high, the thermal limit is not into consideration in that. Voltage drop is not a concern in the high density, so that is false, okay, or both, and the first second is actually true. Here I have kept the explanation also, so I will upload the file, you can read it, okay. Let's move forward, try to solve this problem. This is related to the radial distribution, which is mainly, which I have already explained, but just you have to tick that which option is actually correct for a radial distribution feeder. So this question is basically related to the Rayleigh distribution feeder that I have already explained. So it is asking that whether it is reliable, which is having the easy to protect or economical is there, suitable only for cities and capable for bidirectional flow. So by comparison, you can give the answer. Okay. Try to solve it. Okay, I got few answers. Okay, so it is already been explained that why the radial feeder are widely used because it's a highly reliable, that is false, easy to protect and economical, that is true. Suitable only for cities, false, because the line with the rural feeders are there. There we have seen that it is being used. Capable of bidirectional flow, that is false because the loop feeders are there, which is actually having the bidirectional power flow. Okay, so the correct option is option B. Okay, let's move forward. Here I have given the explanation and you can see further. Here this is already I have explained that in the loop distribution network, so you have the power flow in the bidirectional. Okay, it is not random, unidirectional in the radial feeders, and in the loop distribution you have a bidirectional power flow. Try to solve this. This is already explained, but I wanted to you to revise it. Okay, option B I got answer. Okay, okay, okay. That's true. That's true. That key option B is actually correct. That already explained. When you have the ruler feeder, the distance will be larger. So in that case, the voltage regulation, voltage actually matters. Okay. So that's why the allowable limit is dependent on voltage regulation. Okay. Let's move forward. Try to solve this. I will explain that. That's true. Voltage regulation is correct. Okay. All of you are correct. Try to solve this problem. Okay, I got few of the answers. Let's wait for 1 more minute. Okay, okay, that is correct. Let's wait for 1 minute for others to go through it. Okay, let's dim thing. Okay, let me give the solution. Okay. So when you see the feeder voltage doubled while maintaining the same percentage voltage drop, the feeder can carry the power approximately. Okay. Let's see from the mechanical perspective that when the actually the same percentage voltage drop will be there, if the feeder voltage double, then the power how it is going to. Okay, suppose this is a distribution transformer and this is connected to one generating unit here, and you have a feeder and that is connected to some load. Okay, suppose this is the voltage Vs and this is voltage as Vr. Okay, and the inductive line is there. So what is saying, the feeder voltage is doubled while maintaining the same percentage voltage drop. Okay, so it means that the voltage actually doubled in what sense? So if the voltage increased here doubled, okay, suppose the Vs got increased, so that's why in the same fashion, because the losses will be here constant. Okay, so the Vr will be doubled because what is saying that there is a same percentage voltage drop. So percentage voltage drop will be Vs minus Vr by Vr. It is saying that it is constant. It is constant means Vs minus Vr is equal to constant. So when you are increasing here, the constant will be there. So if you are doubling here, so it will also get doubled in that sense. Okay. So it is maintaining so that the constant it will be maintained. Okay. In the this is what it is actually mean. So when you see that what is the power? Power is basically when you say V square by R. Suppose what is the power to be given here. Okay, so the power will be actually here what is going, suppose one line is there, so whatever the R will be there, means ki resistance will be there, so basically the power will be the V square by R. Okay, so when you see that ki here the VR is actually double, in that sense when you see the four times the distance. Okay, so feeder which is carrying the power, if the VR got doubled, so the power will become four times of the V square by R. Okay, so it is basically the four times the distance. Okay, so because R is proportional to length. Okay, so that's why when you see that R is proportional to V square, when you see the power is actually, I'm considering the power is constant, in that sense R is proportional, R is actually proportional to length. Okay, so when you see the R per unit length here, so multiplying by the L total, in that sense the power will be proportional to length. Okay, means voltage will be proportional to length. So in that sense, when you see the power will be the four times, so the length will become four times. Okay, so that's why the four times became the length in that sense. Okay, let me explain again. So power will be the become 4v square by R. So R usually is the R per unit length. So multiplying by L total. Okay, this is actually what is there. So when you see here, so resistance, when you increase the resistance, length increase, the resistance will also increase in that sense. So the power capability become four times by the distance. Okay. Here I have explained here, so you can see and why it is actually matters. Okay. This is from the same bus bar schemes which we have seen in the previous slides. So here I have kept one problem. It is saying that which bus bar schemes offer higher reliability but requires about 1.5 breakers per unit. It is from the wording also you can see and give the answer. But I wanted to say, can you imagine how the single bus bar scheme was there, how ring bus bar schemes were there, how the transfer bus scheme was there. That's true. That from the statement also you can see that is 1.5 bus bar, that is a breaker and half. Okay. So there was the two breakers were there, and in between there is a one, and this is okay. So this was the bus one, bus two were there, and in between the load can be supplied. Okay. So here will be reliability will be such that when you wanted to operate, so you can operate one at a time and half you can operate. Suppose this is 3. Okay, so the one you can operate and the other you can operate. This is kind of out of 3, 2 will be operational. Okay, suppose you wanted to supply the load 1 and load 2. Okay, here you can say the 1.5 breaker out of 3. Okay, let's move forward. Try to solve this. Which topology is used the metro cities for the high reliability that you have already seen that a loop topology basically used. Okay, here let's try to see the voltage drop in the feeder increasing significantly if. Try to solve this. Try to think. Okay, option B. Okay, C. Because it is asking that when you have the voltage drop in the feeder increases significantly, if the conductor side goes increase, either conductor you having the length or the radius, d diameter, or additional feeder to be added, or feeder length got increased, or power factor improves. Okay, I got multiple options as B and C. Okay, let's see that. Let's see. Okay, what in the question asking voltage drop in the feeders increases significantly if. So this is a formula. Delta V is actually equal to I R pu cos phi plus X pu sin phi. So here when you see the current R is basically proportional to length, which I have already seen, or X is proportional to length. So here you have the resistance here. So when you see the delta V is proportional to length because it is proportional to R. Okay, so that's why when you increase the voltage drop, when you increase the length, the voltage drop got increased, what we have seen in the rural feeders. So that's why the option B is actually correct. When the voltage drop in the feeder increases, it means that feeder length got increased. Okay, let's move forward. Try to solve this. This is kind of demand side management question. It is saying that when you are shifting the electricity uses from the peak to off peak hours. Okay, suppose this was the load curve. Okay, and here this is the peak region is there, so peak time, and this is the peak time. So you wanted a appliances to not operate in this time, you just wanted to operate here, you wanted to operate here. Okay, what kind of scheme it is? last class. Okay, let me explain this. So the option A is actually correct. It is actually load shifting. So here was the operational reason of that load. So that you have shifted to here. So that is called as load shifting. Okay. Suppose this was the load curve and you have shaded that. Suppose this was the some of the operational loads were there and you got removed that. Okay. Means load got disconnected. Okay. In that same, that is called as load shading. Okay. And suppose you are here at time t1, wanted to see what is the power at t2. At time t1, you predict that will be the power at t2. That is called as load forecasting. So the option A is actually correct. Try to solve this problem. Okay. I got the option is C. Okay. That's true. When you have called as prosumers, prosumers are basically the consumers plus generators. Okay, so the generating system will be also there, so it produces also and consumes also. Suppose you have a house, you have a solar PV installation, okay, and there is a distribution substation is there, and there is a line and it is connected to it. Okay, so here suppose the power requirement is 5 kilowatt, okay, and the solar is 7 kilowatt, where the 2 kilowatt generation will be there. Suppose peak it is generating, so 2 kilowatt will go reverse. So here you can say it is 5 kilowatt is a consuming and also 2 kilowatt it is generating. Okay, so that is called as the prosumers, that is it having the both producing capability and also consuming capability. Okay, so that's all for the today's tutorial session. So this will help you to solve the assignment 3 basically. And if we have any doubt in that, if you have doubt right now, just open your mic and ask. Okay, then if you don't have any doubt, just let's end the session here and we will meet in the next tutorial session. That in that we will see that key what are the remaining part of assignment 3 and also see the further assignment 4 theories. Okay, that's all for today. Thank you for joining.